All right, here's our bell work. And so there's what we kind of went over last time with some distribution. We see some combining like terms, principles of equality to isolate, and then divide by the coefficient. So we'll start with the distribution, of course. All right, so for the distribution, first one that I think a lot of you notice, at least you go from left to right like I do, is that there's this 4 right here. But don't forget that it's a -4 because of the minus sign right there that we are actually distributing, okay? So that's -4 groups of 2x's, which would give you -8x's. And then also -4 groups of 1, which would be -4. Now there's another set of parentheses over here on the right, and you won't see that number unless you force it to be shown, which is just a phantom 1. And so, again, don't be fooled by this. It's not just a positive 1, it's a -1. So we're going to distribute that. Remember, distribution is multiplication. And if you need to see that phantom 1 as well, then show it. That's -1 group of 1x, which would be -1x's. And then -1 group of 3, which would be -3. So we didn't touch anything else on this equation right here. So still got the 3x plus 2 minus 8x minus 4 equals 5x minus 1x minus 3. So there's distribution. And now that we have distribution, which again, by the order of operations, you'd have to do before combining like terms, because combining like terms is addition and subtraction. So I see some like terms on the left side of the equal sign, some 3x's and -8x's, which would result in -5x's. And also a +2 and a -4, which would combine to be -2. This will equal, on the right side, I've got 5x's and -1x's, or 5x's minus 1x, same thing. That'd be 4x's right there, and then -3. So what was that, 7 terms down into 4? After using one principle of equality, we should be able to get this down to 3, and then 2 after that. So for me, I'm going to put my x's on the left, and then the numbers on the right, just kind of like what we've been seeing. So this -5x is on the x side of the line, so I don't want this -2 here. You got to zero that out. So I'm going to zero it out by adding 2, but if you do it to one side, you got to do the other side. Remember, you got to line this up with a like term on the right side if you can. It would not be combinable with the 4x because they are not like terms. So, all right, from here, we'll drop the -5x. And then the -2 plus 2, that zeroes out just like we want it to. And then I'll also drop this 4x here. And then -3 plus 2 would be -1. Of course, that shows as -1, which is okay. And now we have this new equation, but this 4x is right here is on the number side of things. So I got to zero that out too by subtracting 4x from both sides. So 5x's minus 4x's, that'd be -9x's. This would equal the 4x minus 4x. That zeroes out like we wanted. Then we'll drop this -1. Final step here is to divide both sides by the coefficient to make the coefficient a phantom 1. So it's a phantom 1x equals, put that in the calculator, you just get 1/9. We want the fraction here. Now I went ahead and put that in the calculator, and on the left side, when I put the x's, or replace the x's with 1/9, on the left side, I get -23/9. That's what I got there, so -23/9. And again, we're checking for truthfulness here, so there's my question mark over the equal sign. When I do the same thing, replace the x on the right with a +1/9, I also get a -23/9. So that shows that it's true. And since it is true, that means that x equals 1/9 is the solution to this equation. But here's our objective. I can solve equations with decimals and fractions. So the only thing that's going to change, everything will stay the same. The process remains the same. Principles of equality, distribution, combining like terms, even dividing by the coefficient, which itself is a principle of equality. All that stays the same. It's just now we're going to be looking at equations that have decimals and fractions. So, like for my end, I don't look at these as though I need to do them in my head, because if I try it, then I usually make a lot of mistakes. So that's where the calculator comes in really handy, because it will do a lot of these operations for you, whether it's multiplication, division, addition, or subtraction. With either decimals or fractions, it'll do it for you, okay? Now for fractions, I'll be using the N over D button, but of course we're going to be seeing some decimals as well, which is the middle button on the bottom, the very bottom row there. Okay, so just take 30 seconds and copy this down. Now we're not going to be doing the fraction computations by hand. But if you did, hopefully this helps you remember, whenever you add and subtract with fractions, you need common denominators before you do that. Multiplication and division don't matter, okay? But again, we'll be using the calculator, so we shouldn't really need that. So what is the solution? Remember, it's the value of x that you could replace x with in the original equation that would then make that equation a true statement. Because remember, even though it's going to show an equal sign, it is conditional as long as both sides are actually equal to each other, right? Like 10 does equal 10, that's true, but 10 does not equal 101. Okay, then that becomes a false statement. See what I'm saying? We have to find a value of x that makes it a true statement. And that's when we use principles of equality, whether it's addition or subtraction or multiplication or division. And I'll just emphasize this hopefully many more times, but with addition and subtraction, remember that is to make zeros, which is what we need to do first, is to make zeros. And then with multiplication and division, this is when we need to make ones. It's usually the last step that we need, because when we make ones, that's to make specifically the coefficient a 1. And yeah, we'll be looking at multi-step equations just like we did on the quiz and on the homework from last time. So remember, even before you use the principles of equality, you should be using distribution and then combining like terms, just like we saw on the bell work. It's just, again, now we're going to be seeing decimals and fractions in the equations. Like this one, here's a fraction in an equation. Now I'm going to compare this side by side with, I wouldn't say it's a common equation, but something that we've seen before, right? So let's make this, I'll make it look pretty similar though. 4b equals 12, okay? Now the one on the right is an equation that we are used to, okay? And if we needed to solve this, I think a lot of you could do that. You'd say, look, we just need to divide both sides by the coefficient, which is 4. And I'm showing this differently on purpose. What this does is it makes the coefficient of b a phantom 1. So again, it's not crossing it out, it's a phantom 1. Because then I get b equals 12 divided by 4 is 3, okay? Then of course you could check, you say 4 times 3 is 12, which is true. But notice on this equation on the right, all we did is divide both sides by 4, the coefficient. Well, the same thing is going to happen on this equation on the left. It's just a fraction. You're going to take 4/3 and divide it by itself, 4/3. And then on the right side, you're going to take 12 and divide it by 4/3. Okay? Now what's going to happen is that's going to be a phantom 1b, which is exactly what we want. But then in the calculator, I'd say 12 divided by, and I'm pushing the n over d button here, and then I do 4/3, enter, and the calculator tells me right away that it's 9. Okay, now the numbers are different, that's on purpose too. The process is the same though. We divided both sides by the coefficients. That's the important part, is that even though we're dealing with fractions or decimals, nothing changes. It's just now you're dealing with fractions and decimals, which the calculator will do for you, okay? And again, you could check 4/3 times 9. You can put that in the calculator. 4/3 times 9, enter, is 12. So when I checked, I got a true statement, which is very nice. Because then I know that that is for sure the correct answer. It's the solution to the equation. That's better. Here's another equation to solve. But again, the process remains the same. Even if it were an equation similar to this, the first thing we're going to do is use, well, the first thing we should do is look for distribution. And then we should look for combining like terms. But I don't see any like terms to combine on this. So we got to go straight into principles of equality here, okay? Now, as usual, I'll say the y's here on the left, and then all my just straight numbers will be on the right, okay? So my negative 3/4 y, that's a good term. It's on the correct side, but the positive 9, the plus 9, it's not a y term, so it's on the wrong side. I will have to zero that out by, well, subtracting 9. It's just if you do it to one side, you got to do it the other side, okay? And then 9 minus 9 is 0. It's true. We'll drop our negative 3/4 y right there, which now equals, yeah, we'll still drop this 2/3 y. And then negative 5 minus 9 is negative 14. But now I have this 2/3 y. It's on the number side of the thing. Well, that's the wrong side. So that means I'm going to have to zero that out as well. So minus, it's positive 2/3, so minus 2/3 y. Now, some students are like, well, how do you put a y into the calculator? You don't. You don't put a y in the calculator. All you're going to do is type the coefficients in. So you're going to say negative 3/4. So negative 3/4. And again, I'm using the N over D button, and then I'd say minus N over D 2/3. Enter, and it shows me negative 17/12 is my coefficient of y here, which equals, yeah, we zeroed out that 2/3 y term, and then we're dropping this. Remember, it's not just 14 there, it's negative 14 because of the minus sign. Now we're looking at an equation right here at the bottom. It's pretty much the same type of equation that we did in that first example, where the coefficient is a fraction. So let's make that a phantom 1 by dividing both sides here by negative 17/12. Okay, so negative 14 also divided by negative 17/12. I get a phantom 1 coefficient of y. Y then equals, so I go to my calculator, negative 14 divided by negative 17. I'm using the N over D button, 12. Enter, I got 168 over 17. And that should do it. Now I checked this in the calculator. So I put the y in as 168/17. And on my calculator I got a correct statement. It just gave me a really ugly decimal one when I said enter is 1.588235294 on the left and also on the right. So it is a true statement though if I replace y with this value. So that's the solution. And keep in mind here, we did start with fractions in the original equation, which would mean that on the homework you would want to write this or type this one in as a fraction too. If it starts with decimals, then you'd type a decimal in as your answer. All right, here's our first equation with a decimal. But remember, decimals, no problem, man, because the calculator knows how to work with these. And the first thing I'm going to do here is I don't really want this divided by 4.8. I would just like the n to be by itself, right? Just want n to equal something. So I want to make that 4.8 a phantom 1. Now it's divided by 4.8, so I'm going to use an inverse operation here by multiplying by 4.8. You could say 4.8 over 1 and then say it's cross simplification. Doesn't matter. It's still going to cross simplify as a phantom 1. Which leaves me with, again, 1n, but I do want the phantom 1. Okay. Now if you do that to one side, you will need to do it to the other side. So multiply the right side by 4.8 as well. Again, I can't do that in my head. I suppose some of you could, but I can. So I'm going to go to the calculator, and it gives me 9.12. Okay. Now I will check. So I say 9.12 divided by 4.8. When I push enter, I should get 1.9. I do. So I found that by replacing n with 9.12 here, I got a true statement. Now I'll point this out again because I know I pointed it out in other lessons. This means that if you replaced n with any other value but this one, you'd get a false statement up here. So there's only one solution here for n. Here's another one. We got some more fractions and even some distribution, no problem. All right. So I will start with the distribution, which starts out with negative 2 times 2/5 x. And again, in the calculator, you just type in negative 2 times 2/5. This will tell you how many x's you would end up with, which shows as negative 4/5 x's in my calculator. And then again, this would read as negative 2 times negative 8 right there, which ends up being positive 16. So we show that as plus 16. And then we didn't do anything with the left side of the equation, right? So it stays the same. There it is. Okay, so what was this, like two slides ago we did a problem like this one. So once again, I'm going to put the x's on my left and then the numbers on the right, although you could switch them. It wouldn't matter, your answer will be exactly the same. And then my 1/5 x, it's a good term because it's on the correct side, but my 1/2 right here is not an x term, so I got to zero that out. So minus 1/2, not only from one side, but the other side. Then we'll zero that out, drop my 1/5 x. Which equals, yeah, we didn't do anything with this negative 4/5 x. Remember, you can't combine this with the minus 1/2 there because they're not like terms. But 16 minus 1/2, I get 31 halves on my calculator. So that's positive, by the way, positive 31 halves right there. And then, still trying to zero out terms, I got this negative 4/5 x on the number side of things, so I got to zero that out. So it's negative 4/5 x, so I'll have to add 4/5 x, not just to one side, but to both sides, plus 4/5 x. So that will zero that out. And then notice here, 1/5 x plus 4/5 x, yeah, in the calculator, it just gives me 1x. And then that would equal, well, we'll drop the 31 over 2. Okay, now the coefficient of x is 1. Just make it a phantom 1. We're done. Okay. Of course, I guess we probably want to check on that. So let's go and put that in the calculator. Yeah, when I put 31 halves in place of x, then I get 3.6 on both sides. So that is a true statement. And again, now I can box that in with some confidence. Now, I like these type of equations. They're not very big, but it's just one step. So that's what I like about it. It's pretty quick. And in fact, the x is just an x right now. So if I could just get this thing dropped, it'd be x equals something, right? I don't want anything added or subtracted to it. So that means I got to zero out that 29.478. So it's positive, so just subtract it. 29 minus 29.478. Just if you do it to one side, don't forget to do it the other side. And, you know, if you can do that in your head, that's fine. I can't, though. So to the calculator, this zeroes out just like we wanted to, but 12.84 minus 29.478, enter. And I got negative 16.638. And then again, just checking, negative 16.638 plus 29.478 equals 12.84. So that ends up being a true statement when you replace x with negative 16.638. Here's a nice two-stepper. So I got pretty much all the p's are on the left, but I got that negative 6 with it as well. I don't want that there. What I'd like to do is be able to just drop this 2.4p. So I would need to add 0 to it, not negative 6. So I have to add 6 there to make that a 0. Just if you do it to one side, make sure you do it the other side, okay? So that will zero that out. Negative 8.7 plus 6 is negative 2.7. And then it looks like we'll divide both sides by the coefficient, 2.4, to make the coefficient a positive 1. So that ends up being p equals negative 2.7 divided by 2.4. You could use the fraction button if you'd like. You should get the same answer, negative 1.125. And like I said, this one started as with decimals. So although the calculator will change this into a fraction for you, if you push the double arrow button just above enter, it will change it into a fraction for you. But we started with decimals, so I'm just going to keep it like this, okay? But let's check. So I can do a negative 6 plus 2.4 times negative 1.125, enter. And I do get negative 8.7, which means that if I replace p with this value, I get a true statement. All right, here we go. Some more principles of equality. Again, there's no distribution here. There's no combining like terms. Got to go straight to my principles of equality. So I'm going to put the m's on the left and then the numbers on the right. So the 7m can stay, but the negative 3.4, I got to zero that out. So we'll have to add 3.4. And then we got to combine it with its other like term on the other side there. So that's going to zero that out. 7m will drop like we wanted it to. We'll drop the 5.8 and deal with it. After this step, 6.12, that's positive, plus 3.4, enter 9.52, which is positive. So there's plus 9.52. Now the 5.8, positive, is on the number side of things, so we can't have that. Got to zero that out too, minus 5.8 m's. So 7 minus 5.8 m's. So that will zero that out. 7 minus 5.8 is 1.2 m's, which then equals, yeah, we'll drop this 9.52. And then finally divide by the coefficient, 1.2. So this says 9.52 divided by 1.2, enter. Oh, it's a 7.93 repeating. I'll use bar notation there. Now I can check with this, okay? So, and I can kind of estimate on this. You just say like 7.9. You can put as many 3s as you want there. But 7 times that minus 3.4 gave me, like, again, I'm rounding here, but 52.13331. I used 9 and then 3 3s. And then 5.8 times 7.9333 plus 6.12. Enter. Yeah. Again, it's not exactly the same, but it's close enough where we can confirm that that would be the correct answer if I could type that in with repeating 3s. All right, here's one. This one has some distribution. And yeah, there's not supposed to be two decimals on it. It's just supposed to be A. Why don't you guys take a minute and try this one out, then we'll go over it. All right, so the first thing we would do on this is to distribute here this -8. Okay, so in my calculator, I've already put this -8 times -4.7 A's, which appears to be 37.6 of the A's. And also -8 times -1.4 would be a positive 11.2. And then, yeah, this still just equals 255.6. Then I would need to zero out the 11.2 because I don't want to combine it with the A's, so minus 11.2. But from both sides, zero that out. We'll drop our 37.6A, which now equals, looks like 244.4 in my calculator. And then one final step. Let's just get rid of that 37.6, change it into a phantom 1, which requires division now. Anything divided by itself is 1. So there's a 1A equals 244 divided by 37.6. Again, just use the calculator. I got 6.5 there. But we can check. So -8 parentheses, -4.7 times 6.5 minus 1.4. Enter. I got 255.6. So that confirms that A equals 6.5 would be the solution for this equation. I can solve equations with decimals and fractions. Hopefully we can do that now, especially since the calculator is doing most of the heavy lifting for us here, okay?